19.7. So then when you look back at your image, you'll be at 19.7 as one standard deviation away. If you go another standard deviation, that would be another 6.2 away. So 6.2 plus 19.7 would be 25.9. And you can continue that way if you want to label it. You don't have to, I'm just showing you. Okay, and you can label the other way, but we know we're at 14 years. So 14 years is going to be positive. All right, I'm going to switch colors here. So if we go with the z-score, with the standardized, we have a mean of 0 here. And then we have a z-score of 1, a z-score of 2, okay, and moving on from there. But the question is at 14. So 14 is just a little ways over from 13.5. And we know how far away it is, actually. We are 0.08 of a z-score away. 0.08 of one standard deviation away. So one standard deviation is already marked on there. So we are just barely over that halfway point. We're looking something like that, probably even less than that, right? And the question is less than. So less than would be everything over here within that curve. Right, so now that we have our z-score of 0 or of 0.08, we need to go ahead and take a look at our charts. Okay, so looking at our chart, your chart will have a negative side and it will have a positive side. We clearly want the positive side. We want 0.08. So looking at 0.08 on your chart, when you look at your chart, the very left values, everything over here takes care of the ones and the tenths spot for your z-score. Our 1 spot is 0, our tenths spot is 0, right? Everything on the top gives you your hundredth spot. That's all the further you have to round out for your z-scores is tenths and hundredths, right? You don't need to go any further than that unless you are working with technology. Technology will provide values that are more correct, that are not rounding. But we're going to work with this here. Okay, so we need to be at 0.0, which would be right here, and we need to be at 0.08, which would be right here. Okay, at 0.08, we have 0.5319. Okay, so we are looking for the probability that our z is less than 0.08. And the probability that our z is less than 0.08 is 0.5319. So how does that relate to the picture? So 0.5319 is your percent chance that somebody has worked for the company less than 14 years. There is a 53.19% chance that somebody randomly chosen has worked for the company less than 14 years. That also means that 53.19% of this curve, of this standard normal curve, is filled in. This makes up 53.19% of the curve. There is a 53.19% chance that a person chosen at random will have been at the company less than 14 years. And there is a 53.19% of the curve colored in. 53.19%. Okay, so that was a less than problem. Now let's go ahead and take a look at a greater than problem. So when you look at greater than problems, remember your chart only goes for values to the left. It only gives you that percent or that probability to the left. We need greater than, which would make it to the right. So question B says, what percent of the employees have worked for the company over 25 years? So over 25. Very first step, find your z-score. Z equals the value. Our value that we're talking about right now is 25. Minus the mean. We're sticking with the same survey or same study. We'll be at 13.5 for our mean, divided by our standard deviation of 6.2. When you math that all out, that will give you a z-score of 1.53. With a z-score of 1.53, that means you are 1.53 standard deviations away from the mean. So you are 1.5 standard deviations away from the mean. The difference here is that you're looking at a greater than. So if you're looking at a greater than, then the area shaded in needs to be over here on the right. And you can already tell, you can see that it's going to be much less than what it was for part A, right? Because your average number is 13.5. We're looking at over 25, so you are quite a ways away, right? So let's go ahead and take a look at our probability table. Remember, your table value gives you the values to the left. We want the values to the right. So in order to find that, we have to take 1, because 1 is the total area of this curve. 1 minus that value to the left. So 1 minus 0.937. And that will give us the probability that our z is greater than 1.53. So the probability our z is greater than 1.53 is 0.063. 0.063. So you have a 6.3% chance of choosing somebody that has been working at the company greater than or over 25 years. 6.3%. When you look at your picture, does that look like 6% of the graph is colored in, is shaded? Your answer should be yes. That's why we draw these out. You don't have to draw them out for every problem, but it provides a visual and a double check for you to make sure your math is correct. Okay, so for the next example, we're looking at what percent of employees have been working at the company between 8 and 20 years. So this is an in-between problem. So this is going to take our less than problem and our greater than problem and put them together to find that middle. So just like the other ones, we're going to begin with our z-score formula. So we have z equals our value, 8, minus mean, 13.5, divided by our standard deviation of 6.2. That will give us a z-score of negative 0.89. Then you do the same thing with the other value. Z equals value 20 minus mean divided by standard deviation to give you a z-score of 1.05. So if we go ahead and draw that on our normal distribution, you'll see that we are incredibly close to what we remember from our empirical rule. So the empirical rule stated that between -1 and 1 standard deviations away, 68% of all of your data values are going to fall. So when you look at our actual values, we have a z-score of -0.89 and a z-score of 1.05, which is just -1 to 1 shifted just a little bit. So when we find this percent at the very end, we should be incredibly close to 68% and following that empirical rule. So let's go ahead and draw it out. So we're at 0, 1, 2, -1, -2. So we have our first z-score of -0.89 and our second z-score of 1.05. And we're looking for in between, so between 8 and 20 years. Right. And just like on the other examples, once we find our z-score, we're able to look at our chart values. When you do the chart values for an in-between, you want the larger chart value minus the smaller chart value. If you did it the opposite, you'd end up with a negative percentage, and we don't want that. So we're going to go with our larger chart value minus our smaller chart value, which would be our larger z-score minus our smaller z-score chart values. So first we're going to look at 1.05. So when we look at our chart, we need to go to 1.05. I'm going to go down. That will put us at 0.8531. 0.8531 is our first chart value. The second chart value is going to need to come from the negative chart because we have a negative 0.89. All right, so we need negative 0.89, which will put us at, we have to find negative 0.8. There it is. Negative 0.89 all the way at the right. So we're going to go down to negative 0.8. will be at 0.1867. 0.1867. Okay, so again, to find our probability, we need to take the larger chart value minus the smaller chart value. So that will be 0.8531 minus 0.1867. 0.8531 minus 0.1867 will end up giving us a probability of 0.6664. So there is a 66.64% chance that somebody has worked at the company between 8 and 20 years, which is very close to that 68 that we were looking for. So, all right, last example. Okay, so what we're going to be doing is using the same formula, but going backwards. Instead of finding a z-score, we're going to be given a z-score to calculate our actual data value that we're looking for. So we need to know maybe what score will put us in the top 10% of the class, how much inventory we need to have in order to meet a certain profit margin, something along those lines. And so what we're going to look at is the backwards or inverse normal. What that is going from percentile, to calculate our z-score, and eventually our data value. When you look at the instructions there, it says the first thing is to find the appropriate z-score. So when we look at our problem, it says scores on an IQ test are approximately normally distributed with a mu of 140 and standard deviation of 35. If only people in the 95th percentile are considered a genius, how high of a score on the test does it take to be labeled a genius? So we need to know our z-score to find our x. So if you think about the formula again, our formula is z equals value minus mean divided by standard deviation. We have the mean, we have the standard deviation, we don't have x. That's what we're looking for, is our data value. We need to find that z. So looking at our table of values, we are looking for 95%. And that 95% is simply located within the entire table of all of the values that are given. It's not quite as easy as just finding your z-score. So if we go ahead and look for 95%, we are looking around the area of 1.7 or 1.6. 1.6 and 1.7 have all the values that are the closest to 0.95. And if you go over into the actual data values, we have 1.64 at 0.9495 and 1.65 at 0.9505. And those two are both 0.005 away, 0.0005 away from 0.95. So our z-score is going to be directly in the middle of those. Our z-score is directly in between 1.64 and 1.65. So directly in between that would be 1.645. So that's the z-score we're going to need to use when we plug it into our formula. So let's move this down. 1.645. 1.645 z equals value, which we don't know, minus our mean, 140, divided by standard deviation of 35. Then you just use your algebra skills and solve for x. So we'll multiply by 35, both sides, and then we will add 140. Once we do all of that, we will end up with a data value of 197.575. That means in order to score in the 95th percentile on this test, you would have to score a 197.575, which would really be a 198. If you scored a 197, you would fall just below the 95th percentile. If you scored a 198, you would fall just above the 95th percentile. So the score on the test that we need is a 198. All right, that takes us through all of our normal distribution. You need to know everything from this in order to move on and do the more difficult concept